Hello guys, so today we'll be doing physics just like last time. Only three questions, momentum of course. So yeah, let's just get started. Um, Hold on. Here we go, where is it? Okay, so for our first question, one ball has four times the mass and twice the speed of another. So we have one ball, it has four times the mass and two times the speed of another. Um, does it have? Okay, I guess it's in the same direction. And this is velocity. Okay. So for part A, how does the magnitude of momentum of the more massive ball compare to the magnitude of momentum of the less massive one? So magnitude of momentum. Well, the magnitude is same magnitude, not direction, by the way. So we just find the ratio between them, I guess. Momentum is m is equal to mv. Now momentum of 1 is equal to mv, and momentum of 2, let's say this is 1 and this is 2. Momentum of 2 is equal to 4m and what? 2v, and that is equal to 8mv. So p2 is 8 times P1. That's pretty much it. That was for part A, of course. Now part B. How does the kinetic energy of the more massive ball compare to the kinetic energy of the less massive one? So here he's involving energy. Um, Now, what's the connection between uh, potential energy, momentum and kinetic energy? They both have V's, so P is equal to M V. How now? Let's see how many V's does. Let's connect V with kinetic energy. Okay. Kinetic energy is equal to 1 over 2 mv squared. Okay, times 2m 2m ke square root is equal to v, and yeah, that is okay. Now what is the question one again? How does the kinetic energy of the more massive ball compare? Oh yeah, just compare the kinetic energies. Um, well, okay, yeah. P is equal to. Do you even need to think about this? One's velocity is twice the other. So no matter what this is, the velocity is gonna be the double. And what's the connection between the velocity and kinetic energy? It's directly proportional. So if one's velocity is doubled, then I guess its kinetic energy increases. I'm not sure if it's doubled or not though. Let's just check. Okay, wait, how can I do this? M square of 2 m k e. I don't know, I just want to try something. I don't know, let's square root both sides, I guess. M2 to m k e to get rid of the square. No, that doesn't, I don't think, that just overcomplicates it. Uh, yeah, I guess just, you just gotta think about it logically. No need to go like dig super deep into it. If velocity doubles, then kinetic energy is directly, it has a like a squared relation with velocity. So maybe k e of the second ball is equal to 4 ke the first. I'm not sure. Just leave a star on it. Anyways, yeah, that was it for the first question. Okay, so I did actually do question 2 right now, but I apparently was not recording, so I'll just go over it real quick. So you have P1. We have two fish, no fishes. Let me just open up the question. Alright, so you have a large fish. This fish has a mass of 25 and swims at a speed of 1 meter per second towards a smaller fish that is not moving. Its mass is 1 kilogram, the mass of the smaller fish. What's the speed of the larger fish immediately after it finishes lunch? So basically, you have object 1 and object 2. Object 1 collides with object 2 and they combine. What's the final velocity? In order to do this, you need to use the law of conservation of momentum. P1, which is the P of the fish, plus P2, which is the P of the smaller fish, is equal to P1 prime, prime means after, plus P2 prime. P1 prime plus P2 prime is basically 25, because P1 is 25 times 1, which is equal to 25. 25 plus 0, this thing is not moving, so it's momentum 0, is equal to m1 v prime plus m2 v prime. V prime and v, these two v's are the same because it's one object and they're moving at the same speed. So you could say that 25 is equal to v prime, factor it out, v prime times m1 plus m2. m1 plus m2 is 26. Divide both sides by 26. And v prime is equal to 25 over 26. And that would be the velocity of the larger fish and also the smaller fish, because they both became one object after the collision. Moving on to the last question, question 3. What's the speed of a 27 kilogram soccer player with a momentum of 550 kilograms times meter per second? Okay, so you have the momentum. Momentum is equal to mv. The momentum of the soccer player is given 550, and that is equal to the mass, which is 75 times the velocity. Velocity is not given. Divide this by 75. Velocity is equal to, let's just plug that into the calculator, divided by 75, and that is equal to, it's about 7.3 meter per second. You get meter per second because you're using SI units in the calculations. And yeah, that was pretty much it. Let me just put a square around it.